All right, we're moving on to our next lesson, lesson 10, which is solving logarithmic equations or functions. So our goal for today is to be able to use the property of equality for logarithmic functions in order to solve. So let's start off by going over the definition of the property of equality for logarithmic functions. It says if b is a positive number other than 1, then log base b of x equals log base b of y if and only if x equals y. So a couple of important parts about that. So notice how they have the same base here. If logarithmic functions have the same base, we can just set the x and the y equal to one another. However, one other thing about this is that it has to be a positive number other than 1. So when you go through your steps and you solve and you get your value, you have to make sure that you're plugging it back in to make sure that whatever you plug in, that number you get for x and y, are a number that is positive and not 1. Okay, so our steps that we're going to take is 1, cancel the logs and set the arguments equal to each other. And then 2, solve for x. Okay, and then one other step here that I should add is that at the very end you want to check to make sure that it works. However, step 3 here says if you have an x squared, you must factor. So that's pretty much just saying being able to recognize that if you have an x squared term, you are going to have to factor, more than likely being the product sum method. So let's go into an example. We've got log base 4 of 3x minus 2 equals log base 4 of x plus 7. And they want us to solve for what that value of x is. All right, first thing that we need to recognize is log base 4 on both sides. They have the same base of 4, which means we can cancel the logs and we can just set the two equations equal to one another. So we get 3x minus 2 equals x plus 7. All right, then we're going to go ahead and solve. So subtract x from both sides. I get 2x minus 2 equals 7. Add the 2. 2x equals 9. And then last step, to get x by itself, we're going to divide by 2. So we get x equals 9 over 2. Okay, we can't necessarily indicate that that is the answer quite yet. We want to check to make sure that when we plug it back in, that value that we get for x and y are a positive number other than 1. So your last step here is going to be to check. So we've got log base 4 of 3 times 9 over 2 minus 2 has to equal log base 4 of 9 over 2 plus 7. Now you can use your calculator to do this. Remember, you can just type it in how you see it on the screen here for each of them. And then you're going to get a decimal, okay, which is 11.5. You can use the decimal, you can use the fraction. It doesn't really matter here because it still gives us the information that we need to know in order to know whether or not 9 over 2 is our answer. So first of all, we notice that they do equal each other. And the second part is that that value, our x and our y here, are a number that is positive and not 1, which means that we can say 9/2 is our answer. Okay, let's move on to example 2. We've got log base 2 of x squared minus 6 equals log base 2 of 2x plus 2. Again, we recognize that they have that same base, which means that we can get rid of our logs and we can just set it equal to one another. So we've got x squared minus 6 equals 2x plus 2. Now, first of all, realize you have an x squared term. By being able to recognize that, you know that at some point you are going to have to factor. However, we cannot factor until it is set equal to 0. So I'm going to keep my x squared positive and move that 2x and the 2 over to the other side. When I do that, I've got x squared minus 2x, and then when I do minus 6 or negative 6 minus 2, that gets me negative 8. And we're going to set that equal to 0. Now we want to factor, so we're going to use the product sum method here. What two numbers multiply to get -8, but add to get -2? Okay, in this case, it is going to be 4 and -4 and a +2. So we get x minus 4 times x plus 2 equals 0. Now we're going to separate those and solve. So I've got x minus 4 equals 0 and x plus 2 equals 0, which gets me to the final two answers of x equals 4 and x equals -2. Now I've got two solutions here, and I have to check both of them to make sure that they work. So next step is check. So we've got log base 2 of x squared. So let's start off with 4. So 4 squared minus 6 has to equal log base 2 of 2 times 4 plus 2. So 4 squared, we get 16. 16 minus 6 gets us 10 on the left side of the equal sign here. So log base 2 of 10. Now 2 times 4 is 8. 8 plus 2 gets me 10. Okay, they equal each other, and they are a positive number other than 1, which means that works. Now let's check the -2. So log base 2 of -2 squared minus 6 equals log base 2 of 2 times -2 plus 2. All right. -2 squared gets me a +4. 4 minus 6 gets me a -2. Okay. 2 times -2 gets me -4. -4 plus 2 gets me a -2. Now this one does not work because it is negative. All right, when I solve, it is not a positive number, so I cannot say that this is the solution, which means in this case, my only solution is x equals 4. Okay, next example, we've got log of x squared equals log of x plus 20. Now remember, we talked about this in the last lesson. If you don't see a base, we can automatically assume that it's a base of 10. So because neither one of these have a base, we know that the base is the same because both of them are 10. So we can go ahead and set them equal to one another. So we get x squared equals x plus 20. Now, in order to factor, I have to set it equal to 0. Again, I want to keep my x squared positive, so I'm going to move the x and the 20 over to the other side. So I get x squared minus x minus 20 equals 0. Now, what two numbers multiply to get a -20 and add to get a -1? Okay, that is x minus 5 times x plus 4 equals 0. Now separate them. X minus 5 equals 0. X plus 4 equals 0, and solve. So we end up getting x equals 5 and x equals -4. Last step is to check. So let's go ahead and plug these back in. So we get log of x squared, so log of 5 squared equals log of 5 plus 20. So we get log of 25 equals log of 25. So it works. Okay, next one. Log of -4 squared. Now it's important to put that in parentheses, right? Remember, a -4 squared is going to get you a positive 16. Okay, negative times a negative gets you a positive. So this equals log of -4 plus 20. So this ends up getting us log of 16 equals log of 16. So these both work, which means my answers are both 5 and -4. Okay, last example. I want you guys to do this one on your own. So go ahead and pause the video, complete the problem, and then play it again to see the answers. Okay, so when you solve, you should get x equals 5. Nice one about this problem is that there was no x squared term, so there was no factoring involved. However, notice that when you plugged it back in, we get a negative 1 as our x and our y value here. And because it's negative, we know that 5 cannot be our solution, which means that the answer to this problem is no solution.